Hi, everyone. Welcome to the Infrastructure Network. Today, we are going to be talking about sewer data. Thank you to all the guests that have joined us on the panel today, as well as all those guests that are watching. And feel free to make comments in the comment sections. If there's anything that you don't like or you do like, please post that in the comments and we'll get back to you and we'll try and respond to your answers as much as possible. But today's goal is to talk about sewer data because it's really important as we transition from traditional ways of doing coding of sewer pipes and manholes to more advanced AI systems and machine learning systems as they grow into being more automated and helping us speed up the process of collecting that sewer data and really helping fix infrastructure. So I'm going to start off with introductions and then we're going to get into the first question. So Eric Sullivan, you are number one to start with your intros. Appreciate you coming and joining us.
Yeah, great. Yeah, thanks so much for having me here, Chad. It's good to be with everybody else. I'll just quickly say I've been in the industry, I think, about 16 years. The whole time I really have had a focus on sewer condition assessment, CCTV specifically. And I've been a NASCO PACP trainer for the past 12 years. And I got connected with Sewer AI because of that. That was about 3.5 years ago now. Was an advisor to the startup for about 6 months. And then we raised funding and hopped onto a full-time role, which was almost just over 3 years ago now that happened. And we went in the marketplace doing that. So I've been doing this ever since as Director of Business Development here. And again, thanks for having me.
Yeah. Thanks, Eric. That was very well done. Christian Koch, you're up next.
Thanks. Yeah, so I'm a founder of Appellant. We are a Swiss-based company working on AI for sewer defect coding. My education is in environmental engineering. I studied in Germany, Switzerland, Spain, and the US. And after my studies, I actually used to think I wanted to become a scientist, but then, we came up with the idea to develop Appellant. It was a research project at our university. And after my studies, I became a certified sewer inspector, first in Germany and then in the US. And I'm glad to be here and to share my knowledge about sewer defect data and the challenges on training machine learning models.
Love it. Thanks, Chris, for being here. Amanda, you're up next.
Hey guys, my name's Amanda. I'm one of the two co-founders of Vapor. We, similar to Sewer AI and Palin, deal with CCTV sewer data. My personal background is civil engineering, much like Christian. On the kind of engineering side and condition assessment, I used to watch CCTV 8 hours a day as my job for Australia's largest water utility. So hail from down under. I'm very, very excited to join this panel.
Thanks, Amanda. Appreciate that. Mike Simpson, you're up next.
I'm Michael Simpson. I'm the CEO and one of the family member owners of M.E. Simpson Company. We are a service business that has focused on providing technical services to water and sewer utilities for the last 44 years. I've done this the last 40 years. My background is in field work. I started testing and repairing water meters in this business and developed leak detection programs on the water side, and then got involved on the wastewater side for, as I refer to it, leak detection for sewers using ElectroScan machine learning technology. And here we are today.
Thanks for being here, Mike. Appreciate that. Thanks. Lots of experience in this panel. I'm loving it. And Eric, you're up next.
Hi, I'm Eric Dupre. I'm the president of Texas Infra Group. We specialize in basically pairing technologies from data collection all the way to final procurement. So our clients that know exactly kind of what overarching issues they have, let's say it's sanitary sewer overflows, they're dealing with EPA consent decrees. We help them package how to identify the problems, the sources, and then do design builds to kind of bring in teams to pretty much do all the procurement that's specific towards what we capture in the data and see as being the main problem. So I'm hailing out of Texas, and so most of the clients that I deal with are here in Texas. We got a couple of people we're talking to in Lake Charles, Lafayette area in Louisiana, but mainly most of the work's in Texas. So we just try to focus mainly on sanitary sewer defects and SSO mitigations to where the systems aren't leaking anymore. So that's what we specialize in.
Awesome. Thank you, Eric. And I forgot there's two Erics, so I got to be more specific on which Eric I'm speaking to. I'll work on that. I'll try.
The ball-headed one with glasses.
Right.
Yeah, good luck with that one. We'll see where this goes. All right, guys. So thank you all for being here. My name is Chad Smeltzer. I'm the host. I've been out of the sewer business the last 2.5 years, but I'm moving towards procurement and a way to simplify the procurement process and help businesses create a digital footprint and build their culture and start connecting to government buyers on a platform. So needless to say, sewer data. I've had experience with sewer data. I've been in the industry for like 20 some years in sewer. One of the things with sewer data is there's challenges. So one of the questions I have to start us off with is, what are some of those challenges we've experienced with sewer data? And I'm going to ask each one of you to kind of give us a response to get the conversation going. So I'll continue with Eric Sullivan. What are some of the challenges in sewer data, Eric?
Well, there's a lot of it, for one, and I'll just only really speak to CCTV,
Sure.
Visual data on the inside of the pipe. But yeah, I mean, for the past 30 plus years, there's been some pretty robust programs in different utilities here in North America with CCTV inspection. So there's a lot of legacy data. That's for one. And I think everybody here would agree. There's a lot about the sewer environment that makes it hard to collect good video. So there's all kinds of challenges optically that come into play, whether they be related to flow or just debris, anything like that, as far as that goes. But I guess I would say, because probably there's so much of this data and there's been different standards that have existed over time, and definitely that applies to different regions, is that, we bump up into database migration issues all the time. And there's a lot of different catalogs that, exist. And, here in the US, it's mostly NASCO, but there's different outliers as well, some custom ones. So yeah, things like that can really hamper the effectiveness of getting the data, in and out of different platforms to be able to analyze it, right? And the whole point of why it gets collected, why it gets analyzed, is to enable engineers to make the right kinds of decisions about capital planning and asset management, right? So to be able to get it in that format, so that people can collaborate on it, simply is one of the main things. But as I mentioned, the capture of the data too is a challenge. That's not to be overlooked. That's just kind of one thing I would say right off the bat, if you're asking me first. Yeah.
Hey, that's great points. It gave us a good starting point to give us some more conversation going. And Christian, you're up next.
Sure. Yeah, totally agree with the different catalogs, coding standards. Generally speaking, I think the data source is very heterogeneous. So we have different types of cameras, pan-and-tilt cameras, 3D side scans, drones, satellite cameras. Then these cameras have different resolutions. So we start with standard definition, high definition, 4K now, maybe soon for 8K. So also different, these affect also the machine learning models. And then lastly, we have the human influence, in particular with a pan-and-tilt camera, depending on how the human being is panning and tilting inside the sewer. This mainly heavily affects at the end how well we can code effects. And secondly, I think I would like to point out issues with the metadata. At the end, like metadata is being recorded on site. Let's say like the diameter of a pipe, right? And it's very, very difficult afterwards to measure the diameter of a pipe, and we depend on the sources, and all the quantifications which are being done afterwards, they depend on this input data. So yeah, like many, many challenges involved in trying to clean that up.
Yeah, good stuff. Amanda, you're up next.
Echo what Eric and Christian have said in terms of specific the data set that we deal with as well. But I think even what's unique about sewer data is that it's one of those assets that's kind of out of sight, out of mind. And so if you're going to collect data on it, it is quite hard and quite challenging and therefore expensive. So really just understanding why you're capturing data and then, insert all the reasons that Eric and Christian have already mentioned in terms of actually moving the data and creating it. But just even kind of creating that story, zooming out and saying like, what is the data telling me? What are the insights I'm getting out of this? What are the actions that I'm going to be able to take away from this data set that I've invested a lot of money in? That I'd say a lot of people need some support on. And yeah, I think that's also a challenge as well.
Yeah, good stuff. Mike, you're up next.
Coming from, what I would refer to as a pure field perspective, the first, and I think what everybody said before all alludes to the first problem for a vast majority of utilities is, and I like Amanda's out of sight, out of mind, because that's a true statement. So the information that they have about their system sometimes is missing. It's non-existent. It's just lacking in so many areas. And that's the key part, is where do you start? And you're trying to track infrastructure, and you're trying to figure out what the condition of, what is level of condition. From our perspective, using the machine learning tool, using the ElectroScan, that's one of the benefit adds of using that tool, is it's going to find all the defects in the pipe as you drag it through the sewer, and find all the little different interesting things. Now, granted, does not have a camera component, which can be very valuable in certain situations, but that's what we have cameras for in CCTV. But one of the key elements to the ElectroScan and using machine learning technology is now we're gathering this data, and we know where all the defects are, so we can make some really strong decisions on how we're going to address this segment of pipe, this section, this area. And when we can actually truly see the total infiltration, and put an actual gallon per minute value on it. So we can make, again, it's always financial. I said this yesterday, or Wednesday in a presentation. We can talk about all kinds of things and all kinds of fun, fluffy buzzwords and conservations and ESGs and all this other really nifty, neat stuff, but it always comes down to the same thing, and that's money. And this is always about money and how much it costs to fix, or how much whatever, it's money, and how much we charge our customers from end to end. It's always about money.
A very interesting perspective and true. Eric Dupree, you're up next.
So holistically, everything that they're talking about, you've got bits of information from here and here and here. And so at the end of the day, you need to make that information meaningful. So if you collect this data, that data, at the end of the day, what's most meaningful? Michael nailed it kind of on the head. At the end of the day, money and ROI, return on investment. These are assets, large quantities of assets. And so you have things like condition assessment evaluation. So you've got a grading system 1 through 5 that coincides very easily with ASCE's report card grades A, B, C, D, and F. And so in my opinion, for 4 years, I was a board member of a utility district here in Houston. And so their asset management was horrible. It was scattered all over the place. You had multiple people and vendors giving information here, here, and here, but they didn't condense all this information to centralize all this data in what I would consider an asset management optimization system, some place where you can house all this data and say, what are the top priority things? Like return on investment's important. So like an asset can have a bunch of cracks in it, but there's another asset just down the street that has less cracks, but it's next to a creek. And so how much I&I is coming in through that particular asset versus the other asset. So you might have gobs of water infiltrating at that particular location, but the other one had a worse condition of its overall rating. So it's got more structural cracks or failures and things like that, but it doesn't paint the whole story. So like when you get data that actually can quantify I&I, and you're like, well, this asset is producing this amount of I&I, but the other one's producing much less I&I. Well, which one's costing you more at the end of the day? So be able to collect this data and then start centralizing all this data so that you can kind of scorecard each of these particular things. So if an owner says money is in ROI is top priority, the actual structural condition is the next priority, and then you got a list of 5 other things and you prioritize all that stuff, you can kind of scorecard all these assets and color code them, look at all these things and rank them. But you need to take all this information and centralize it into some kind of asset management data system so the owner, the engineer, and decision makers can have a centralized place to go to. So like one of the things that's kind of weird to me is ASCE comes up with all these report card grades of how bad the infrastructure is, but yet they don't have a centralized database of all this ascertained data to make these scorecards. So I think it's a great idea to rank the assets and identify this, but you have to have a centralized database to support those types of figures. So, so in the big picture, the cornerstone of all this is definitely, if it's sewer, it's I&I, SSOs, compliance, money. So you need to know what condition the asset's in, and then you need to know how bad it's leaking in and leaking out.
Right. Yeah. So there's basically what everyone's saying in the beginning of this is, there's a lot of data that is scattered. It's archaic. It's all over the place. It's not in one place. There's a lot of money that's going to need to be found to fix all the defects that we end up finding, right? And then we have the ability to, with all the software systems that the teams that are here now, the companies that are here now representing that software component of building these databases so that we can quickly prioritize the repairs, right? You guys are using different types of AI, right? So we're collecting this data and we're putting together a lot of information for the government entities, the owners, to make better decisions on their capital projects, so to speak. But what is Eric, you mentioned something about the legacy data, database migration issues. What can you elaborate more on that? Because here's what I know in my time being in sewers is it's controlled by either the engineering firm, the owner, or somebody. Like, how are you getting that data from these firms?
Yeah, when we do an engagement with the utility, they'll provide it to us. They'll upload it to our platform. As you mentioned, a lot of times there's an engineering firm involved on behalf of the utility. The engineer of record. They may themselves physically possess the data, or they may be able to help coordinate, exchange of the data. That's usually how that goes. Definitely, it's not generally open sourced. As far as I know, there's not a place you can go to watch a bunch of CCTV video of sewer just online. Some things on YouTube, I suppose. But it generally is a pretty committed conversation, and it's not regarded as for public consumption. As fun as it is to watch sewer videos. Usually it's directly from the owner, the utility itself.
Yeah. So I guess I'm going to elaborate a little bit more to that. So I found it's difficult sometimes to get data from these other organizations that are out with the owners, because you don't want to give up that information sometimes because it's valuable. We're looking at data in a whole nother world right now of actually the value of the data, right? That's there.
Yeah.
And it can be controlled. So how do we get over that hurdle? I guess kind of what's going on, because Eric, you've kind of said that you've run into engineering firms that you're competing against now in bidding processes and stuff like that. That's kind of the stuff you're struggling with. How does go ahead?
Yeah. Well, okay. So I think maybe a fundamental question that we could talk about would be, to what extent is new software and technology starting to, in some cases, supplant what engineering firms have done for many, many years. If you can create a way to efficiently and consistently and accurately, assess the condition of a sewer based on a video, right? That's something that, used to take, a lot of people, a lot of time, right? And these are very educated people. These are experts. Their brains are probably better used to do other things than watch sewer video is one thing that everybody kind of knows. But at the same time, some of these engineering firms, some of them that we've come across, have been a little bit resistant and have said out loud sometimes like, hey, we have billable hours here from doing these tasks manually. And, if a vendor comes in to, augment that, the engineering firm then needs to figure out how else it's adding value in the engagement it has with the city. There's so many things that engineering firms do beyond sewer assessment. So that's usually not a big deal. But there have been a few times where there's been some, at least trepidation from engineering firms. And then there are engineering firms that are actively pursuing artificial intelligence, computer vision specifically, where with tools, very similar to, what Sewer AI, what Vapor, what Palin have been bringing to market already.
Yeah, nice. Christian, you want to add some more to that?
Yes, I could add to that. So generally speaking, like Amanda mentioned in the beginning, that gathering this data is costly. And I do agree, but I actually would claim or say that maybe we don't invest enough money in gathering this data, because at the end, inspecting a meter of a pipe costs a couple of dollars here in Europe, right? But building in your pipe, like a meter costs thousands of dollars, and every dollar invested in gathering the data and making sure that we have high quality data in order to make those decisions is actually saving engineers time watching the videos, but also allowing them to make better decisions. And we have been quite successful working with the engineering firms here, because at the end, they lack still human workforce to watch these hours. It's really difficult to find people willing to spend hours watching CCTV videos. And for them, they usually make more money in planning or designing rehab measures instead of doing quality control on the defect coding data. And that's why many engineering firms now use our service. They even use it sometimes when they have already coded data from the inspectors, because they get so much more efficient in the condition assessment part, and they can use their limited workforce to focus on the rehab planning where they make more money out.
Okay. Great. Thank you so much. Amanda, you're up next.
Yeah, I think it's really an interesting problem to think about when you've got like competitors coming from unexpected areas. But even just to go back to your question, Chad, on the data and how it's being valued, it really is that new currency now in terms of people are becoming more cagey about the data. Rightly or wrongly so. They are seeing it as more of an asset where they were before. It was more transactional. Some interesting stuff that it's even happening in the UK, where they're aggregating data and open sourcing that. I think that's a really, really exciting sign that will give more kind of fuel to the industry, create more options for asset owners to avail of AI solutions. I think that sort of stuff where people are becoming more data savvy is going to be really only reap rewards for the industry and move us all forward. So, you see that stuff in kind of the open source movement where, things like GitHub and open source data has just created so many options in the market for consumers to work from. So, more open sourcing of data will help the industry move forward. So, only good signs for everyone.
That's Mike, I'm coming to you next. So there is a lot of positive stuff with AI and machine learning that's going to come out. It's going to make us more predictive maintenance, right? It's going to help us with improved efficiencies. It's going to enhance the data analysis. It's going to bring in, stop overflows, environmental. It's going to reduce the impacts with all the data that we're collecting, right? It's all positive. But if we're looking at the data in a way that it could be in a negative, it can be used to influence capital projects. It can be used to create a place where it can be used as an advantage, competitive advantage, if it's not somehow monitored, or I guess with the owners, because the owners seem to be, in my experience, okay with just getting the data. The contractor has the data, the engineering firm has the data, this owner has the data. Like there's really, it's kind of scattered throughout all over the place right now. So as we look at AI and machine learning, it's got a lot of positivity, but it also can be used as a way to, have a competitive advantage. Sorry, Mike, you're up. Go ahead.
Oh, it's an interesting, concept. And, I look at it I always look at stuff because our entire business model and our entire business over the last 44 years really been based on gathering data. I've got databases for thousands of utilities in the U.S. And, that's one of again, still with all my 40 years of experience, the one thing I continue to run into and find everywhere I go is actually the lack of data. It's not even who holds it or controls it. It's the fact that it still doesn't exist at a point. It's amazing what we don't have and what people don't have. My favorite is, getting the shape files from a community to look at their distribution and collection systems, and they'll freely admit that, well, all this came from the Mylars from 1972 that they pulled out and they scanned in, and now it's in their cool new whatever they bought GIS package. And we just on a water topic, we just we're doing some remote leak detection for a community in the Chicago metro, and it was very fun because according to the computer, the leak was over here, and we sent people out and to verify and correlate and physically look at it, and the leak was 100 feet over there. And during the meeting, there was a discussion, and even the GIS technician who runs that utility said, yeah, our map's wrong. The water main was in the wrong place. According to the map, it was, like I said, it was in one spot. And in reality, physically, no, it's not. It was 100 feet over here. And now the data has been corrected, but that's the whole problem. It goes back to everything everyone's talked about I go beyond data ownership. I go back to the fact that our data is still lacking significantly in a lot of places. And, I'm all for open source and all the other things, but ultimately the key effort is we have to spend the money to go out and physically collect the data. And that's where people are still struggling, is going out and getting all that information and having it at their fingertips.
Right.
With today's technology, theoretically, it should be relatively simple, but it's still going to take time.
Yeah, you're talking about something that I've experienced too with the GPSing of assets. It can be off 15 feet if they didn't use the right survey equipment. There's all kinds of stuff we can talk about with that. But Eric, go ahead. I think you probably want to add some to this.
Yeah, I mean, this whole AI across the board, artificial intelligence, it's going to take manual processes and delete a lot of them. And so you're not going to need as much laborious, time consuming things, because you have things that aren't going to get bored. They're going to be able to see the same data and then spit out, very consistent results. That's the whole premise of doing some of this stuff. The manual processes in many, many industries, they're going to have to rethink all that. And, if it was part of your business model to do all these manual processes, but the problem is we have to have a rapid response to a failing infrastructure in the United States right now. And to have a rapid response, you need qualified, good, consistent, current data of what's happening right now and seeing what area it's trending in. And so those manual processes and who has access to who used to do that process before, at the end of the day, the owners need to look at all these options. And so they need a lot of good data in the right places, and it needs to be accurate, and it needs to be rapid, and then it needs to be affordable. And so when you can package all those things together, you can give them a high value. So all this has to end up going back to the owner, because they're the ones that had to make all the decisions. and it gets a little weird, I guess, because, like I'm certified as a, asset management, certified with BAMI through the asset management certification process. And so that's asset management, and planning and designing and all this stuff. Those are engineering. And so we're kind of getting in a place where are we needing engineering, or do we need asset management? And who's certified, qualified to do it? People with experience and that are certified in asset management. Those folks, in my opinion, if you've ever taken the asset management class through BAMI, which is Dr. Tom Isley, Louisiana Tech, I mean, these guys put together one of the most comprehensive, smart asset management certifications I've ever seen on planet Earth. And so if you have somebody that has those types of certifications and they know exactly which data needs to be extrapolated and then condensed and then put into a format that's fast, it's visual, color coding things is amazing. Once you can prioritize all these assets to what the owner says is high priority and important, then you can color code that collectively. And then you can make a map where you got green, yellow, red, color coding to where it tells you which areas of your assets and which locations you need to go attack heavily to, mitigate those issues in that area. And then, green's good. If this area is green over here, it probably tells you need to migrate to a red or a yellow or, some other color coding. So simple, taking a lot of data that's complex, but then simplifying it through some kind of asset management tool. I think that's really what's going to be needed to springboard all the stuff that Eric and Mike have. You take all this information from this source and this source, and then the owner has to prioritize based on what EPA says, regulations, money, and then put that all into a software that can analyze that and then collect all that data rapidly and then put it into a system that can output a visual graphic so that decision makers can make rapid decisions. Because if they can't make rapid decisions and we still do these slow, drawn out processes, we're not going to get ahead and fast enough to identify key sources and areas that are really making massive impacts to SSOs and I&I. And it's just going to cost the taxpayers a lot of time and money that honestly we don't have either of them right now.
Right. So you're talking about a couple different things there. Where is, Palon, Sewer AI, Vapor, they are in their technologies can basically quickly analyze pipe data and prioritize it for repairs. I mean, everybody seems to be on a similar path for that. Mm-hmm. So if from what you're saying, Eric Dupree, is that if there's a quicker way to get real-time data faster, right? We can process that information. Say a contractor goes out, televises, 2,000 feet or 3,000 feet in a day. They can get that data back to the software system. That's going to produce an end result, right? Or some kind of repair recommendation, some kind of recommendation of what to do next with that pipe, which, the software systems that are here today as guests, they're pretty much able to do at this point. So if that's the case, getting real-time data and finding ways to prioritize the system and getting repaired quickly, what's interesting is Mike saying that we don't have the data, but where are we missing something? Is it just contractors aren't adapting the software fast enough to use it within their companies? Or, Eric Sullivan, I'm going to come to you, but where's that going? Are we not getting contractors adapting this with their CCTV equipment?
Well, you hit on a really important point there about the fact that the AI computer vision technologies enable a workflow in the field now where there isn't a lot of data entry going on, right? That TV operator now does not need to be an expert on sewer condition assessment. They need to be an expert on, let me get this robot from A to B and get it out, keep the lens clean, make sure I got the right wheels. To say it very simply, right? That's a huge benefit for any contractor, okay? Mm-hmm. To be able to onboard an employee and very quickly make sure they get a NASCO certification and they understand, the context of what they're doing, but not the actual details. And again, not needing to be an expert, have that employee within the first month start to be as effective, more effective really than a very experienced one. That's huge. Or the ability to have a cloud platform that has all the data for the project, to be able to share that quickly with a chain of custody with the stakeholders to get paid faster. Yeah. And, you know, one of the conundrums that just comes up is that, you know, any contractor that we call on is already a profitable business, and they've already been doing it for sometimes decades. So there is a bit of a chicken or the egg moment that does occur in different markets, usually where there's an owner that needs to, you know, sort of either provide a blessing or the demand to the contractor to say, hey, we're changing our spec. This process is now going to change. You're going to do it this way. In some cases, you have contractors that are early adopters that are willing to do that. And then in some cases, there's an engineering firm that sees value in it and is willing to facilitate it as well. You know, and
Yeah,
they happen. They're all very different. You know, Amanda, you live in the UK. I guess there's like 13 water utilities. There's tens of thousands here in the US alone, to say nothing of Canada. So they're all different. But yeah, there's a lot of different conversations that happen. I guess the one thing I would point to that's been said here about like the challenges of like, I guess, obtaining the data, you gotta incentivize someone, right? So for a utility to just hand over a bunch of data to an AI firm, that's a little bit weird. I mean, it happens sometimes when they really want to help, or there's a specific project that they think that their data is going to help you fulfill for them. But you gotta provide value in hosting it for them, and you know, features around that. You know, really that's really one of the main things that a lot of folks like us are trying to do, I guess.
yeah, good points. Christian, you want to add anything to that?
Yeah, maybe a small point about data-driven asset management. I think that's the way to go at the end. You know, right now, many decisions are being made experience-driven. Somebody knows the network. He says, this year we're going to do that pipe. Next year we're going to do this pipe. And the bigger this network is, the more difficult it becomes for a human being in order to make the right decision, to prioritize the right pipes. Eric Michael in the beginning said, hey, we need to look at infiltration, inflow. There are many variables we need to look at, right?
Right.
And I think it's the way to go into the direction of data-driven asset management. But to go there, we really need to make sure that the input data we are generating, that's the defect coding data, which heavily influence the condition assessment, is correct, as accurate as possible. And in fact, we are nowadays often work for cities network operators in Europe who have inspected the full network 1, 2, 3 times, and who want to go into the route of data-driven asset management, but they know that their data is subjective, that maybe some defects are not being coded as there should be, and we often analyze the historical data. So we really specialize in doing the data analysis. We don't do yet, you know, like let's say we have recommendation, all the stuff afterwards, because there are many softwares out there who can do that already, right? But I think the missing piece in the whole value chain is to make sure that the defect coding data is as accurate as possible, and that afterwards the models can work well.
Interesting. Amanda, you want to add anything? Sorry.
Yeah, just to kind of touch on, well, I'm just going to go back to your original question of like, you know, what is missing in the supply chain side of things in this adoption. I think it kind of, you know, Michael hit on the head in the initial question of just ROI. You know, like I don't know that the supply chain or asset owners are missing anything in adopting this. It really does come back to what Michael said on terms of the ROI. Like, can you demonstrate using your technology that there is an ROI on the data collection? It is super expensive at the moment. You know, it's the job of the supply chain as well to bring down that cost using innovation. And you know, we're all, you know, everybody on this call is on that pathway to bring down that cost. But demonstrating the ROI, I don't believe anyone's missing anything. It's just kind of, you know, up to us to demonstrate that in a compelling way.
Yeah, good points. Mike, you want to add?
Well, I mean, I think ultimately it's getting the owners, the engineers, everybody more into adapting to the new technology. I mean, I look at it from the perspective, you know, we use the ElectroScan tool, and that tool has proven time and time again to be much more accurate and efficient and quicker than CCTV. I'm not disparaging or discouraging CCTV and people wanting to use cameras in instances, but in reality, I can run the ElectroScan probe through 3,000 feet of sewer and provide you umpteen tons of greater, more accurate, and effective data than you running a CCTV camera through and have somebody spend the next 20 hours trying to look at all and find all the defects, viewing videotape that I can hand you in a matter of about 15 minutes from a cloud-based format that can dump into Eric's Sewer AI and be coded out for long-term planning. But it's getting people to adopt and adapt to new technologies.
Yeah.
You know, we're dealing with an industry that when the industry, and especially here in the U.S., and Eric hit the nail on the head, there's about 50,000 utilities in the United States, and getting them to change what they've done for umpteen decades is a Herculean task. And as I tell people, when the water and sewer industry is moving at lightning speed with their hair on fire, it's about the same speed as a glacier moves. So you know, it's different, but that's the thing. I mean, I am a huge fan of artificial intelligence and machine learning and making the data go faster and getting the information as quickly in my hands as possible so I can mitigate the problem. But it's getting people to adopt and adapt to this new technology. That's the toughest part. And again, Amanda keeps saying it, and I'll keep saying it. I need to see an ROI because it's always about money, and that's what they always come back to. Show me the money. That's you know, where we're at.
No, they're really good points. Dupree, you want to add?
Yeah, I will say one thing that's interesting is that we're talking about mainly, I would say 99% of everything we're talking about public, you know, wastewater infrastructure. So what's always blown my mind is, you know, who actually owns that data? The taxpayers, the American people. So like those groups and those agencies, where do they source their money from? Is from taxpayers. Taxpayers are paying for all of this stuff. So at the end of the day, like if I lived in the, you know, greater Houston Metroplex and I pay taxes to them and I have an AI company or any kind of company and say, well, we don't want to give you that data. I said, well, that's public data. You know, the public paid for it, right? So, you know, it's kind of weird how they would think about it being theirs. I'm like, it's our data. It's not his data. Or it's like, it's collectively, it's all of our data. And so if I was ever to hit kind of a brick wall saying, well, we're not going to, number one, if the owner tells any of its vendors to share the data, they will. That's who's in charge at the end of the day is the owner, you know, and whoever the owners are, whether it's a city manager or director of utilities, whoever, at the end of the day, you know, this is public data. And if we have a better, more efficient way to utilize that data for us as taxpayers, you know, it's also lack of policies. So some of the stuff, like in each state, they're in charge of policies. So like in Texas, we have approximately 4,200 systems independently owned and operated of water and sewer in Texas. So on the condition assessment evaluation, the state of Texas does not have a requirement to do a condition assessment on any kind of time period. They don't require you to report your ASCE report card grade to the state of Texas in 5 years, 10 years, or 50 years. It's not a policy at all. So, you know, yeah. And this is how it is for majority of the states. They don't have a policy to say you need a complete condition assessment of your entire system. And then that assessment is then reported to a centralized agency. Like in Texas, we have what's called TCEQ. So in my opinion, the state of Texas is lacking in policy, saying that if the state of Texas as a group wanted to know its overarching scorecard evaluation for its entire sewer systems, for all 4,200 systems, how does it know? In 2023, how does it know collectively what they don't know? Because they don't have a requirement to say you need a complete condition assessment of all your assets for your sewer And that needs to happen on a time period every, I would say at least every half a decade, because you have a starting point, and then you have the next point and the next point. And then once you have multiple points, you can see how it's trending and what direction it's going.
Yeah.
If you don't have a baseline condition assessment and then you don't have a secondary one, you got no course of direction of how it's trending for one owner, let alone 4,200 owners to see how the whole state is trending. So that, Texas Water Development Board, they fund a lot of projects. And if they knew that this pocket of Texas or this pocket of Texas has got a low scorecard of a C- or a D, they need a lot of help. If these areas over here are all like A+ and B+ and stuff like that, they, in my opinion, time, resources, and things like that. So without this kind of data and without better policies, the policies are going to dictate to some of these owners, because out of 4,200 systems, they all have 4,200 different philosophies.
Yeah.
And if the state doesn't have some kind of reasonable requirement, if you're going to levy taxes, it's impossible to not have current, accurate condition assessments of your system. Because if you don't have current, accurate data for your current system, how are you assigning a repair cost, a rehab, or replacement cost to any of those assets? So then how in the world are you actually coming up with a valid, appropriate budget? As a mud board director, we didn't do that at my mud district. So first thing I said, we have this budget. I said, yeah. I said, number one, how many of those assets do we have? And are they broken out by segment, by pipe, manholes, lift stations, and all that? They're like, no. I said, that's the first thing we need to do, is quantify how many assets we have, number one.
Yeah.
And then number two, we need to know what condition they're in. And then number three, we need to know how bad each one of those assets are leaking. And then how bad it's leaking assigns you an annual cost of what that asset.
And I mean to cut you off there. You're talking about advanced asset management systems. I mean, in general, we're talking about sewer data right now and what that's going to look like in the future with AI and machine learning. That's really where I think we can finish out, because we got a limited amount of time. We got 13 minutes left. But everyone, what do you think the future of sewer data is going to look like in the next 5 to 10 years? Eric Sullivan, you're up.
Oh yeah. So one of the things that we've really seen take hold has been the prevalence of action cameras, GoPros. The optical quality of those has gotten great. In some cases, magnitudes better than a much more expensive CCTV crawler system. When you look at it that way, 5K, 8K stuff. And Christian mentioned some of that earlier too. And we're seeing that with the right software, users in the field can really start to use simpler hardware. And I'm expecting the trend to continue of the cost of inspection is going to continue to go down. And one of the factors is going to be that the CapEx outlay for a contractor or a utility starting up, a inspection crew, that's not going to be nearly where it has been historically. There's always going to be a use for robotic crawlers, I believe, in pipe. There's a lot of use cases for that. But there's also a lot more use cases where it's sufficient, in some cases superior, to be using a 360 GoPro, for example, whether it be manhole or pipe inspection. Similar to that, and then Christian, I know you mentioned this earlier, drones. That's for bigger pipe especially. I think a use case that's going to continue to grow. So you're going to see like the optical quality go up. You're going to, in some cases, see the hardware costs go down. And I've seen more and more folks become more interested in cloud and less sort of averse to that. And as just AI in general becomes more prevalent in everyday life, I think the level of comfort that just culturally people have and need to have is going to go up too. So there's a few things pointing to more, better, faster, cheaper.
Advanced camera systems and things like that are going to make it even better for, I would assume, just prioritizing the code, and the AI system's the images would be better
I mean,
perceived with an AI? I don't know. I'm just throwing
garbage
it out
in,
there.
garbage out. The better the optical quality. The more pixels, the more potential that there is for it to detect. Generally speaking, yeah.
Chris, what do you think about the future of sewer data?
Yeah, totally agree with most of the points Eric mentioned. Like I think quality of image resolution will go up. People will inspect more and faster. Maybe cost of the equipment will go down. New types of inspection robots, such as drones, are being used more and more. But what I also think is that maybe we will start valuing the data more, and we will actually start using this data more actively. As I said, right now, many decisions are being done on an experience level, because it's very, very difficult for human beings to work with large amount of data. But machine learning or computer models can work with large amounts of data. And I'm super interested actually in predicting the future state of a pipe, right? Like if you have a history of data and you have coded on a consistent, accurate level, then we believe, that you can actually predict the future state of a pipe, that you can help utilities set up investment strategies. And now, hey, if you spend this amount of money in the next 5 years, the value of your assets will evolve in this direction. But you could actually also start investing a bit more, and that will allow you in the future to save costs, right? And so I believe that on the one hand, we get better data, but we will also make more use of this data, and that will allow us to decrease the cost in the future.
Yeah, good response. Amanda? Oh, we froze. You're good. I think you're good now.
Oh, okay, I'm back.
There you go.
Yeah. So I think from my side, I think the predictive capability that Christian mentioned is something really, really exciting that's coming out of the huge data sets that's coming out of the sewer network, really. But even just the pipe systems, the water systems, any infrastructure, really being able to generate, using AI to generate unprecedented volumes of data, where people had to kind of choose between quality data and quantity of data, and it was like and or it was an or. And now with AI, you have the ability to say and. You can have quality and quantity, so that's really exciting. And it opens up huge opportunities, even just like dovetailing sewer data with other data sets. So like drinking water, like telco. So we see huge opportunities, even just dovetailing information that we have with optical fiber, and even satellite data. So yeah, we already mentioned drones and other data sets, but just satellite data to apply, like where there's sinking of ground areas near sewer pipes and things like that. So there's a huge amount of data being generated now, and dovetailing and creating like a contextual layer to decision making that's happening real time is really exciting as well.
Yeah, you're talking about what Eric Dupree was talking about, advanced advanced asset management systems. That would be the ultimate goal, right? Have all your infrastructure laid out and telling you what your budget's going to need in the next 5, 10, 20 years, whatever that's going to look like. Mike, sorry, kind of jumped in there, Mike, but go ahead.
Right. No, I was going to say in the comment box, there's another Eric who made a comment where utilities are stewards of the public infrastructure and have every right to be protective of their data and assets. And I wanted to say that it's a misinterpretation of what everybody's saying. We certainly know that our water and sewer assets don't need to be on Google, public information. You're 100% right. The owners of the utilities do have every right to protect that data, and I would want them to. We were more referencing where individual I'm not even going to say firms or whatever, people do data for the owners, and then they hoard that data and use it to their advantage, so no one else can quote work there. I think that's really what we were referencing, is that and that hopefully the owners of the data, the true owner of the utility themselves, always makes the information available to their providers, contractors, AI firms, whatever, technologists, whatever, so that they can build upon it and add more. So wanted to get that confusion. I think the ultimate thing here too is as technology gets more efficient and more effective, there's no question it may get less expensive. But ultimately, I think one thing I want to make clear is what we need to get owners to do is to become more comfortable with technology. And I'm the guy that is the non-camera guy that's using a different form of technology that I believe gives us even more and better data beyond pictures. And I'm not picking on anyone, but I'm saying that people need to be much more open-minded and look at new and inventive technology that gives you greater access to data in a faster format and more data. But no matter what it is, no matter what you're doing, the ultimate goal is to collect as much data, accurate data, as humanly possible, so that we can, again, in the end, what Eric Dupree said about regulation, and with Texas, or Indiana here with our Department of Environmental Management, doesn't matter, that we're doing the best we can for our utilities, because ultimately the ratepayer and or taxpayer, which is one and the same in general terms, is the true owner of the product, and they deserve to get the best value they possibly can for the bill they pay every month or the tax bill they pay every year. Doesn't matter. It's the same difference. That's the ultimate goal here.
Good stuff, Mike. Eric Dupree, you got 2 minutes.
Yeah, so the data and the technology that Eric Sullivan with Sewer AI, that's extremely important data. The stuff that Mike collects is extremely important too. So collectively, if you have all these data collectors to get to an overall arcing understanding of what is or isn't happening in the sewer system, let those companies do what they do best, cloud-based, all the data, do what they do, so that the owner doesn't have to encumber it, all those issues. The engineers don't have to encumber it, becoming data collectors, and have let them, they've already figured out their niche systems to a T, but an advanced asset management system tool where you plug that data and that information from these various sources of data gets plugged into. We just want the answer from Mike, and we just want the answer from Eric plugged into a proper asset management tool that can then identify very simply for the asset owners, what's the next step? What's the most logical next step, priority, and hotspot? You go attack the hotspots that are costing you a ton of money and a ton of SSOs, environmental health issues. Let's attack those spots and work backwards. And once you do that, you're going to be utilizing your tax dollars at the highest degree. So like what Eric wants to do, what Mike wants to do with anybody collecting data, they just want to stay in their lane and do those things. But an advanced asset management tool where it's plug and play with the answers from the trusted vendors, it would tell the owners exactly what to do in 10 seconds.
Yeah, it sounds like we need to do another episode on advanced asset management down the road for sure, Eric. That's the future. So I hope everybody learned a lot today. I did. I got different perspectives from everyone that's on the panel here. You guys did a great job just giving us some different ways of looking at things throughout the globe, really. Chris and Amanda, you guys are at different parts of the globe, so to speak, and it's great to get some different perspectives than just the United States of what's going on. But thank you guys all for showing up and being here, and I hope the event was helpful to anybody out there listening, and thank you all for joining me. Have a great weekend.
Thanks.
Appreciate the opportunity.
Thanks,
Thanks, everyone.
Thanks, guys.
Yeah.